Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to show how to calculate what are called centroids here. So what we're going to do, we're going to look at my favorite example function here, y equals x squared. We're just going to restrict ourselves to the first quadrant here. We're going to look at the region from x equals 0 to x equals 2, and we're going to calculate the centroid of this region. So the centroid is some sort of spot here. It's a set of coordinates. Right, so usually this is fairly standard notation for a centroid here, x bar, y bar. We're going to learn today here how to calculate the location. Now before we actually work on calculating that, I'm going to start by talking about grade points, right? Because centroids are calculated in a very similar manner to how your grade point is calculated. So let's say, imagine one semester you're taking physics, right, which is maybe a 5 credit hour class. And then we take, calculus something or other, and it's a 4 credit hour class. And then we take English something or other, and it's a 3 credit hour class. And then the grades that you get, we get a pretty good grade in physics, 3.0, and a good grade in calculus, 3.5, and a 4 point in English. So now the question is, how do we calculate our average grade point for the semester? Now, what you can't do is just add these and divide by 3. And the reason is because these classes have different weightings to them. Physics is 5 credit hours typically here, so it's worth more than, say, English, which is 3 credit hours. All right, so when you calculate your grade point, you have to assign a weight to it. And in this case, the weight is assigned by number of credit hours. So our grade point, the way we calculate it is you take your grade, 3.0, and you multiply by the number of credit hours, 5. Plus the grade in calculus, 3.5, multiplied by the number of credit hours, 4. And our grade in English, 4.0, multiplied by the number of credit hours, 3. Now you'll notice that each term is a grade times a credit, grade times a credit, grade times a credit. We want it to work out to just your grade. So what you do is you divide out the total number of credits, which in this case would be, 9 and 3, 12. So you notice now that each term is grade times credit over credit. So each term is a grade. And what we're doing is, again, this is called a weighted average. We are averaging the 3, the 3.5, and the 4 and weighting it by the number of credit hours. So let's go ahead now and talk about how we use this concept up here to calculate a centroid. All right, so what we're going to do is we're going to start by drawing what's called a differential element to use. Now that element could be horizontal or vertical. I'm going to go ahead and draw a vertical element. Oops. There. And I'm going to imagine this element has a width dx. The length of this element is equal to the y value here, or the function value. And what I'm going to do now is look at the centroid of this rectangle. Now, centroids are calculated by weighted averages, and they can be calculated, sometimes are calculated by weighting them by mass, and other times by area. What I'm going to do is I'm going to do the weighted average using the area of the rectangle to give the location a weight. If this geometry is uniform, like the density doesn't vary left to right or up and down, then the centroid calculated by weighting it by area versus weighting it by mass will be in the same location. Right. So the setup is all about this. Let's talk about getting x bar here. The x coordinate of the centroid of the rectangle is just x. So what I'm going to do here is say, right, we're going to have x. That gives the centroid of the rectangle in this set of coordinates. Now I'm going to give it a weight. We're going to multiply by the area of the rectangle, which is going to be the length, y, times the width, dx. These are then added up, x running from 0 to 2. Now, again, this is basically what we're doing. We're trying to find the average x value, weighting it by area. So it's the x location of the centroid of this rectangle times its area. Then what we do is we divide out the total area. And the total area under this curve is going to be the integral 0 to 2 of, we'll just say y dx for now. Y dx being the area of the rectangle. Right? So if we go ahead and, let's see, work this out, we're going to have the integral 0 to 2 up top. Y is equal to x squared in this example, so this ends up being x to the third dx over. And down here, let's see, y dx, y is equal to x squared, so that's going to be the integral 0 to 2 x squared dx. Up top, that's going to be x to the fourth over 4, evaluated 0 to 2. In the bottom, this is going to be x to the third over 3, evaluated 0 to 2. So let's see, we're going to have 2 to the fourth over 4 over 2 to the third over 3. And let's see, that's going to give us 2 times 3 over 4. 3 halves, or about 1.5. Right? And if you look at the geometry, 0 is on the left, 2 is on the right, so 1.5 is about here. That looks about right. So again, the key is that this is a weighted average. Right? You are averaging the x-coordinate of a whole bunch of rectangles. That's that distance in green, so that's what this is representing. You give it a weight, that's this, by multiplying by the area of the rectangle. You'll notice as these rectangles move to the right, they have larger and larger areas because they're getting longer and longer. So they weigh more, so to speak, in the average, right? And then in the end, you divide out the total area. Now, there's the calculations for x bar. Now I'm going to go ahead and set up, or go ahead and calculate y bar. Oops. I want to get rid of this. Okay, and I'm going to go ahead and just use the same rectangle. Now in green, the y-coordinate of the centroid of the rectangle is this vertical distance here. Right? This distance now is half of this function value. So that's equal to y over 2. Now we're going to give it a weight. We're going to multiply by the area of the rectangle. That's going to equal y dx. These are then added up, running x from 0 to 2. And just like before, we're going to divide out the total area, which will be the integral 0 to 2 of y dx. Okay. Now, let's work on the top integral here. So this is going to be y squared, and y is equal to x squared. So that top one is going to be the integral 0 to 2 x to the fourth dx over 2, and that over 2 is from this, divided by, in the bottom, integral 0 to 2, and let's see, y is equal to x squared. I'm going to take a moment just double check this before I move on. So that's y squared, y is x squared, so that's going to be x to the fourth. Yep, looking good. All right, now we just work the integrals. That one is going to integrate, let's see, x to the fifth over 5. Keep in mind there's a 2 down there already. Bottom one is going to integrate to x to the third over 3, just like it did before. That's going to give us 2 to the fifth over 10 over 2 to the third over 3. I need a little more room here. Oops. Take this entire thing here and just move it over to the left some. All right. Oops. So let's see, being kind of careful here, we're going to have 3 over 10 times 2 to the fifth or 2 to the third. That's 2 squared, which is 4. So 12 over 10, 1.2. So the coordinates of the centroid of this region are x bar equals, I think we had 1.5, and y bar 1.2. So that's basically how you calculate centroids. You draw a differential element, which will, in this case, will be a rectangle. You write out something or take note of the coordinates of the centroid of the rectangle. In this case, that's right in its geometric center. This distance is x, and then this distance in this example would be half of y, or y over 2. These distances will vary some depending on your picture and the orientation of your rectangles and such. Then what you're averaging are these things. You're averaging this x value and this y value. And I already did the x value, but when we average this y value, that's this, but you have to give it a weight, and that's what this term does. And then ultimately you have to divide out the weighting or the area, and that's what this does for you. So anyway, this is meant to be just kind of a general video on how to calculate centroids. I hope that this helps demonstrate this process. Have a great day.